This is Josh White from JW Math Tutoring. Today's video is going to look at 10 problems from the November 2024 Digital SAT Math section. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Just before I begin going through these 10 problems from the November 2024 Digital SAT Math section, I just want to mention a couple things that I always mention before these specific types of videos. So first, a lot of these problems are going to be done as free response. However, on the test, they might actually be multiple choice, meaning you might have, answer choices to choose from, in which case there are alternate methods that you could use to solve the problems, that I can't really do as I'm doing them right now as free response questions. So do keep that in mind. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications as well. Also, you will start to see in this video, if you haven't already, some repeat questions. Questions that have maybe I've previously gone over that are very similar or almost identical from October or from back in August or previous months. So yes, it does appear that the College Board is essentially reusing questions, specific question types, just with different numbers or very small variations. Okay, so just be aware of that. Otherwise, if you have any alternate solution methods to the ones that I've shown here, please do leave them in the comments. I'll make a separate follow-up video where I show alternate solution methods as well to these problems and the rest of the November 2024 videos. All right, so let's go ahead and get started now with question number 1. So this one looks like a fairly complicated problem, and it is because you have to set up the diagram and everything, but once you do that, it's actually not that bad. So what ends up happening is we have an isosceles triangle, okay, where AB and AC are congruent. So I'm going to put A up here, I'm going to put B here and C here. Okay, so these two sides right here are congruent. Also means that this angle is congruent to this angle, angle B and angle C. That'll come into play later. Now, point D is on side BC, so down here, what we call the base, where DC is 5/7 of BC. So that means 5/7, notice, is more than half. So that means that point D is like more than halfway over here. So maybe it's like right here, okay? And then we also have E being placed on AB, so whatever, I'll just put it here. F being placed on AC, such that angle BED, so first I just have to connect E to D here, and DFC, so I also have to connect D to F here, are congruent, okay? So, for example, now we know that these two angles here are congruent. All right, one more piece of information we're given, DE is 10. So that's everything that's provided so far, in the problem, and now they want to know what is basically the length or the value of DF. So what actually happens here is these two triangles that I made at the bottom, BED and CFD, they are similar to each other because there are two pairs of congruent angles. So by the AA similarity postulate, i.e. we have two pairs of congruent angles, basically what we know is that EBD is going to be similar to, and I got to make sure I get this in the right order. So I start up here at E, which is angle congruent to it is F. Then I have to go to C, and then I end at D. Okay? So now, notice that DE and DF, those are going to be corresponding sides. So it's whatever the scale factor is between the two triangles, that's going to help me get, from DE to DF or, vice versa, however you're looking at it. So what you know is the following. And I'm just going to make up some numbers here just to make it easier to work with, but BD is 5/7 of BC. So what that means is, say, just hypothetically, this whole thing was 7. 5/7 of 7 is just 5. So like this thing right here would be 5, and then this over here would be 2. So the whole key here is now we have the scale factor between the two triangles. Basically, it's like they're in a ratio of 2 to 5. So it's like if you look at the small one, the side is 2, to the large side is 5, CD to BD, and then that's going to be equal to the same proportion or same ratio as DF, which we're solving for, to DE, which is 10. So now you could just solve this. You could just, I mean, you can cross multiply, or you could just multiply by 10 on both sides. And like 5 goes into 10 here twice. 2 times 2 is 4. So DF in this example would just be 4. Okay, so your correct answer would be 4. Now, the fact that I chose 7 here doesn't, like, that doesn't really matter. I just chose that to make the nice, easy numbers to work with. Technically, if you want to split this up, it's like this is 5/7 of whatever x, your total side length here is, and this would be the remainder, which would be 2/7. So you could say 2/7 x. So even if you use those values, it's like 2x over 7, 5x over 7. Like, if you just reduce this down, the 7's cancel out, the x's cancel out, and you still get the same ratio or the same scale factor of 2 to 5, looking from small to large. Okay? And that's basically the key to figuring out the problem. All right, next up, number 2, we have a very common question problem type, one that we've seen on multiple tests now dealing with percentages. So in this one, you have A being equal to 22.25%, which as a decimal is 20.25, and then the sum of B and C. And then you're also told that B is 81%, or as a decimal 0.81, times C. So now they want to know what percent of A is B. So notice when you're looking at the end here, it's like what percent, X percent, of multiplied times A is B. So that tells me at the very end, I want my final expression to be B alone equals something times A. And that's going to get me my answer. All right, so now what you can do is basically solve this second one for C by dividing by 0.81, and then you would plug that into the original equation because we want to get an equation only with A and B in it. Now, for this part here, just to simplify this, basically, I'm just going to just ignore the B part here. And let's just focus on the numbers. So we've got, basically like 1b plus 1 divided by 0.81, okay? So this is the number you get. If this is how many b's you get, like inside the parentheses, it's 2.23. I'm just going to approximate it here, but of course I'm going to use the exact value in Desmos. So now that's going to be multiplied by the 20.25 out front, okay, which is just equal to A. So now I can just put the 20.25 out front here. Okay, so I get A. So A is equal to 45.25B. All right. And remember, we want to know what percent of A is B. That means we want this solved for B. We want B equals everything else on the other side. So just divide by 45.25. 45.25. B is equal to, basically the number that's going to be multiplied by A is 1 divided by 45.25. So now what I could do in Desmos, I could just type it in, or if you just define this, like whatever, I'll just define this as like D, just do 1 divided by D. So that is the number that's multiplied by A, 0.022099, blah, blah, blah. But it's asking for a percentage, so you have to convert this decimal to a percentage. So now you would just multiply by 100 to convert the decimal to a percentage. So the correct answer is going to be, let's see, 2.209 if you truncate it, 5 total characters. However, if you round it, it's just going to be 2.21 because this 9 would round up to 10, and then it would be 2.210, but you don't need the last 0, after the 1, basically. So just 2.21. So either of those would be accepted as correct. Now, just to show you, here's how you could do the entire problem and like calculations and everything just in Desmos. So first thing I'm going to do is I'm going to define B as 81% of C, but I'm going to let C equal 100 just as my starting point. Okay, so I've got that, and then I know that A is equal to 25% of B plus C. Okay, so now it gives me, so now I have a value for A. So now I'm trying to figure out, what percent of A is B. So if you go back to the equation right here, again, notice the way uh, that it worked out is we had A equal to some number times B, and then we ended up dividing by that. So now if you look at that equation and think about it, we can just basically we can just type it out as an equation and it'll give us our answer. In other words, what percent, X percent of A is equal sign B. And we can just type that in and it gives us a vertical line here. Now it rounds, so 2.21, which is what we consider correct, is fine. Let me just see if I do regression, if it would give us the exact, yeah. So if you technically use regression to solve it instead of just typing the equation here, so you make this x1 and you use the tilde, now, okay, notice it gives me the 2.20994, and here's where you could either truncate it or round it, to either 2.21 or 2.209. Okay, so this is how you could just do all the calculations just entirely basically in Desmos. All right, next up at the bottom of the page, we have a basic trigonometry problem. So on this one, essentially you have a right triangle. Okay, it's ABC. We know that AB is a leg, so I'm just going to label it like this. And we also know AB is greater than BC. That tells us that these are both legs, okay? So that means the triangle has to look like this with B as the right angle. If you like put A and B at opposite ends, like A and B here, then AB would be a hypotenuse, but again, that contradicts the fact that it tells us it's a leg. So the triangle has to look like this. Again, you could switch C and A, but the point is B is the right angle. So this is 38. I just want to know which of the following is equal to the length of AC. So notice these are all expressions are all in terms of sine. So all you have to do is remember your basic, trig, SOHCAHTOA, and you could say cosine A equals adjacent 38 over hypotenuse AC. And then we rearrange this. AC times cosine A equals 38. Divide by cosine A. These cancel out. AC is equal to 38 divided by cosine A. So the correct answer here is just going to be letter C. All right, next up we have a unit conversion problem. So on this one, basically you start with 5,000 feet per hour, and we're just converting to miles per minute. So hopefully you know that 1 hour is equal to 60 minutes. So you can multiply by that, hours on top, minutes on the bottom. And then for feet to miles, because we're trying to get miles per minute, we are going to have the 5,280 feet in 1 mile on the bottom, and then the actual 1 mile on top. Now, let's see, hours cancel, feet cancel. We have miles per minute. So this, we just go ahead, we go into Desmos, and you're going to see there's technically 4 different answers you could put for this problem, which should all be considered correct. Okay, so notice here, so your answers could be 0.157, excuse me, 0.015, that's if you truncate it, 0.016 if you round it, 0.0157 if you truncate, or 0.0158. if you round. So again, 4 different answers: 0.0157, 0.0158, 0.015, 0.016. Yes, those are the 4 possible correct answers that you could have for this unit conversion question. All right, next up we have one you probably recognize if you checked out my other videos. This one is basically a repeat question with pyramids. So you've got a square base on the pyramid. They give us its total surface area. They give us the basically lateral face area, which is like the 4 triangles. They want to know what the height of the pyramid is. So this one, basically you go through the, essentially the same process for all those types of problems. It's just going to be different numbers. So we start with the total surface area of the 19,968. We subtract from that the lateral, we call the lateral area of the 13,884. That gives you an area for just the base of 6,084. Now, since the base is a square, to find the length of each side, you're just going to square root that. So if you do that, you're going to get the length of each side as 78. Okay? So each edge here for this base is just 78. Next, what we have to do is we have to take the lateral area and divide it by 4 to find the area of one triangle. All right, so now let me just jump into Desmos just to make sure calculations are correct. So each triangular face has an area of 3471. And if you look at a triangular face now, its base is 78 and its height right here, this is technically the slant height of the pyramid. It's usually abbreviated with the letter L. And that's going to be the area, that's equal to the area of one of these faces. So this is equal to 1/2 base height, but again, the base is 78 and the height is the slant height L. So now if you solve this out, basically 3471 times 2 divided by 78, that's going to give you your slant height, and that should be 89. Just confirm this in Desmos. So again, I'm taking this, this number, multiplying it by 2, dividing by 78. Yep, slant height is 89. So now what you end up doing is, I'm just going to see if I can erase this red part. Not completely messing up the diagram. Okay. You make a right triangle with the height. So let's like the height is coming down right here in the middle. And you have the slant height as the hypotenuse and half of one of the edges. And so 39 will be one leg, and then the height will be the other leg. So you have 39 squared plus h squared equals 89 squared. Now, there's multiple ways you could solve this. I would just recommend going to Desmos. You could just type it in, squared, like this. Then you do have to get to zoom out and look for where's the vertical line here. Okay, it's on 80. So that is the correct answer. It is 8. The height turns out to be 80. However, I will show you a neat little trick that you can do that's a little bit quicker and doesn't involve any zooming on the graph. So again, if you use regression and you make this x1 and you make this a tilde, now it just gives us the answer. We don't have to zoom out and look for any vertical lines on the graph. It just tells me right here, x1 is 80. Okay, so that's how we can find the height of this pyramid given its total surface area and its lateral surface area. Next up, we have a problem which basically appeared to be kind of brand new to this November test. I think on the test, the way this one, it was actually given as a picture, not given as coordinates like I did it. Meaning the actual problem had a picture here with a line segment, but it's still the same basic idea, same basic principle. So you have one side of a triangle, and it basically is at like -2, 3, let's say where this is, and then it ends at like say 5, 10. These are just numbers I made up. And then you were told the area of the triangle and want to know what is the length of the other leg. So all we're doing is basically, using the area formula, 1/2 base times height. We know the area is 20 root 2. And then the base, the height is what we're going to solve for. The base, here we're just going to use the distance formula to find the distance between these 2 points. Now, if you want to, yeah, you could do like 5 minus -2 squared plus 10 minus 3 squared, and then do all that workout and everything. But who wants to do that? We can just go to Desmos. And we can just use the distance formula with our 2 points. Now the problem with this is it does not give us, it gives us an exact value. I'm just going to define this, by the way, to be b, our base. It does not give us like the nice radical value, which is what you would get if you actually do it by hand. Because if you do this by hand, it's going to be the square root of 98, which just simplifies to 7 root 2. So if you do it by hand, you get 7 root 2, and then that just plugs in here. And notice what happens is, oh, I forgot the 1/2. Need the 1/2 out front. The root 2's cancel. You multiply this by 2. You divide by 7. So the height in this case just ends up being 40 over 7. And now you could, of course, put that as a decimal equivalent, 5.714. Or maybe it's multiple choice, it only has the fraction, who knows. If it's response, of course, you could also put the 5.714. Now, I will say, then what you would do, if you found the distance in Desmos, okay, using the distance formula, and you defined it here, then basically you're just setting up a basic equation, right? And you're just doing the area, which is 20 square root 2, equals 1/2, and then times b, which is going to carry the value down from above. And then here I'm just going to put x. And so here it gives me 5.714. But again, if we want to know the exact value, maybe more exact value, maybe I would do regression and just do it like this. And now here it's 5.71429, so it has to be 5.714. I don't think, if you just type 5.71429, yeah, it's not going to give you, it's not going to give you the nice 40 over 7, unfortunately. Basically what you'd have to do is you'd have to take, essentially do what it did by hand, which is take the 20 square root 2, multiply it by 2, divide it by 7. Let's see here. Yeah, multiply by 2, divide by 7. And then, why is it not giving me, let's see here, what's its, times 2. Let's try this again. Oh, I need, sorry, I'm doing this incorrectly. I need to basically do, sorry, it's 20 over 2 just going to be divided by b. Times 2 and divided by b is what I need to, excuse me, is what I need to do. Times 2 to make up for the 1/2, and then here's where b goes. Okay, so now this is actually solving for the height, and now if you click this, okay, now we have 40 root 7. So again, what I was just doing is like, I had 20 root 2 equals 1/2. This is the b value that was stored in Desmos, and this is h. So to solve this for h, again, you're just doing times 2 and then dividing by b. So this is what you could type in to Desmos to get the exact value. All right, next up, we have another repeat problem. This one first came up, I can't remember, back in March or May. But essentially, the whole trick or key to this one is, so when you go to factor this, if you're going to use like the AC method, you multiply a times c, 34 times 50, right? And it comes out to 1700. And then you're thinking, okay, what are some factors of 1700 that add up to, they're going to add up to b basically. And you can go through like all the different pairs of factors and everything. But it turns out the largest values that you're going to get for b is when you end up factoring it as just with 34 and 50. By the way, you can change the z to an x, and you can change it from 18 to squared and g to the 9th, x to the 1st. Like that part, doesn't matter. And then just plus 1 plus 1. And so you end up multiplying this and you get 1700. You multiply this and you get 1 and it's 1701. So with these problems, the trick, the shortcut, the method that they've always worked out is basically you multiply these two values together and you add 1 to it. And that's going to be your answer. And it's always going to like essentially work out that way. It's the maximum value of b, the middle term. Okay, next up we have some cylinders, and basically one's smaller, one's larger. One's volume is, however many times the other one's volume, and they want to know which of these combinations could represent the radius and the height of the larger one, basically like relative to the radius and height of the smaller one. So a couple things. First of all, volume for a cylinder, it is given on the reference sheet in Blue Book, just pi r squared h. So essentially, what you're really, let me just look at my notes here. What you're really looking at here is like not ignoring the r and the h, the numbers that you're plugging in. So for example, if you look at A, when you plug in, instead of like doing r, so for the first one, the volume is just, pi r squared h, and that's it. And then when you go to plug in the values for the larger one, right? If you plug in 4r here, notice the 4 gets squared because the radius is squared. So it really becomes like 16, there's a 16 multiplier from the r, from the radius, but the height, it's just 8. It's not squared. So in other words, the total volume for B will end up being 16 times 8, or 128 times greater than A. And we're looking for 256. So that's really all we're doing. So like on the next one where you take 8 and you square it, and then the 4 doesn't get squared for the height. This is like the radius, this is the height. So 64 times 4 becomes 256. This is going to be the correct answer. And then for C, you could do, it's 2 squared times 128. That's 4 times 128. That one comes out to, I think, 512. Yes, 512. And then for the last one, it's 4 squared times 64, which is 16 times 64. This one is 1,024 times greater. So that's kind of like the theoretical approach behind it. You could also technically just like let r equal 1 and h equal 1 for A, and then think of all these as like actual numerical values. Okay? And so, for example, for cylinder A, the volume is just going to be pi, because 1 squared is 1 and h is 1. And so if you want to do that, it's basically picking numbers. I would just go to Desmos, and I would just set up the formula, and your formula is just pi times, r squared times h. Okay, like this. And then what I would do is I would just add sliders for various things. So for example, in the first one, r is 4, and h is going to be 8. And now what I would do is I would get rid of the pi, because that part doesn't matter, right? The part that really matters is what's the number times pi. So see, you can see this one for A, it's just going to be 128. And then if you go change it for B, see now it's 256. And then you can see for C, it's 512. And then you could also plug it in here for D, 1024. Okay, so B is going to be the correct answer. Now for the next problem, below at number 9. Here you basically are given a function, and they tell you that f of a plus 4 for this function is equal to 16. Want to know what's the value of a. So a traditional way to do this would be set this function equal to 16, and then go ahead, solve this out for x. I mean, this down here, I'm just going to make x squared plus 6x. So then you could just cross multiply, and you're going to get 16x squared plus 96x equals 7 minus x. Then you get 16x squared plus 97x minus 7 equals 0. Now, this will not factor, so you're going to have to solve this either by using quadratic formula or by, going to Desmos. So if you just go into Desmos, you can just technically type, we can type the whole thing out. Just make sure we got that right. 16x squared plus 97x minus 7. Okay, so now the two values of x that we get are 0.071, negative 6.134. Now, those are both basically equivalent to a plus 4, because when we plug in this number, we get 16 as our output, as our y. So we just set each of these equal to a plus 4, and then we solve that. Or in other words, really just subtract 4, from both of these values. So for the a value, you're just going to get, let's see here, negative 3.929, negative 10.134. And just go to Desmos, confirm that I did that correctly. Negative 3.929. Okay, so that one's good. And then negative 6.134. Okay, so that's good. So those are the two possible correct answers. You can submit either one. Now, you can also actually do this entire problem in Desmos as well. So all you would do is, I would take the original function, just type that out. Okay, then once we have that, I would make a new function, and in this new function, I'm going to just basically make, inside the parentheses here, put, instead of a plus 4, you technically have to put x plus 4, because it only graph in terms of x, it won't graph in terms of a. So you just replace this a plus 4 with x plus 4. So now the new function I want to look at is the purple one, okay, not the green one, so we'll deselect that. And I want to see, where is this function equal to 16? So I'll graph the line y equals 16, and I have 2 points. Negative 3.929, okay, that matches my first answer. And what else do we have? Negative 10.134, okay, that matches my second answer. So that's how you could do this one entirely in Desmos. All right, the next question. Here we have a circle, equation of a circle, and they tell us what the radius of the circle is, and they want to know what the value of t has to be in this. So first I'm going to show you how you could do this by hand, and then after that I will show a Desmos method, but it's not entirely done in Desmos. You do have to do a little bit of manipulation first. So essentially what you're going to do is you're going to go through the process of putting this into standard form. So first thing you do is divide everything by 2, and you get x squared plus t over 2x, and then we're going to put a blank, and then we get y squared plus t over 2y. Now this becomes negative 30, and I'm just going to add that over to the right, and we have 2 blanks over here. Okay, so now if we were going through the process of completing the square, basically the way that you're going to think about this is that you need to make 38 on the right side, right? Because if the equation is equal to 38, then that's the r squared value in the standard form equation of a circle, y minus k squared equals r squared, and then r would just be the square root of 38. All right, we already have 30. That means we need to add 8 to that. So these two blank spaces basically together need to add up to 8. And they're going to have to each be 4 and 4 because we have the exact same values here, for the t's and everything. it's t over 2x and t over 2y, which means it'll be the same number in the blank. If one of them was just t over 2x and the other was ty or 2ty, then they could be different. It could be like 2 and 6 or whatever. But because everything's the same, that's why how I know it's got to be 4 and 4. So if you go through the process of completing the square, the way it works is you take the b value, t over 2. Okay, so that's equal to b. Then you take half of it, meaning you divide it by 2. So that becomes now t over 4. Then you square that, and that value, which is t squared over 16, excuse me, that's technically what's going to go in the blank here. It's also what's going to go in the blank here as well. So we need these to each equal 4, which means t squared over 16 must equal 4. In other words, t squared has to equal 64. Therefore, you square root both sides. T has to equal 8. So the correct answer for this is going to be 8 for the value of t. Now, we can just go to Desmos and confirm this, not solve it, but just, confirm that this is the correct answer. So I'm just going to type in the circle. I'll just fill in the values. Okay. For t, just type in 8. Okay. So now I'm going to click the max and min points, and I'm going to find the distance between these 2 points, which is, and then that'll be the diameter value, and then technically I'm going to divide that. So it's -2, 4.164. Okay, and the other one is -2, comma, negative, let's see here, something, -8.164. So this is just the diameter value, top to bottom. So if I divide this by 2, now I get the radius. So I just want to confirm that that is equal to the square root of 38. And it is. I mean, obviously it's not exact because I didn't have exact values for the points here, but you can see it's close enough. 6.164, 6.164, blah, blah, blah. Okay, so that just confirms it's correct. Now, the way you could do this in Desmos, okay, it requires a little bit of work or a little bit of knowledge. My experimentation, you have to basically set the two equations equal to each other using regression. But the original expression that you're given here has to be divided by 2 first. So what I mean by that is if you just try to type this in, okay, so now we're going to set this equal to basically essentially the standard form equation, and the whole key is that we want this. The standard form equation is basically going to have this 38 in it because we want the radius to be equal to 38. So I'm just going to do this. All right, so now, right, because x minus h squared plus y minus k squared. Okay, and then because you would subtract 38 over and it would be equal to 0. Now what we have to do first is we have to define x1 as a list. Okay, we also, because we have second variable, we also have to define y1 as a list. Okay. So if you notice here, what happens is when I do that, it does not give me, it technically doesn't give me the correct values for t, h, and k. The h and k part I'm not so concerned about. It's more the t value that basically I know is wrong. And if you see here, even if I add more, things, it's not giving me the correct value for t. However, okay, if you edit this and you divide everything by 2, Now, okay, so here's the full regression statement. If you divide the original function that you're given by 2 and use that form on the left side, notice now it gives you the correct values for h and k, and also more importantly for t. And it gives you right here, let's see though, it's technically giving us -8. The only problem I just noticed is when you do the square root here, technically it could be plus or minus 8. So I guess in this problem, the way that it would have to be worded, or because both positive and -8 would work. Essentially, one of them is a circle with the center at like 2, 2, and the other one is one with the center at like -2, -2 down here. And then, but they each have the same radius. You know what I'm saying? So if you look at it in standard form, it's either going to be like they're both going to be equal to 38. It's going to be x plus 2 squared plus y plus 2 squared equals 38, or x minus 2 squared plus y minus 2 squared equals 38. So either would be correct. So I'm assuming that the way this problem is worded, and I'll probably change this language on the final PDF file, is that t is a positive constant, or negative, or it could be, I guess, negative constant, either one. So, because technically you're getting two answers. However, if you go back to the regression statement and we put in this qualifier, okay, see now this gives me the equation that I had originally, where I just assumed that t was positive. T is +8 and the h and k are both -2. That's the circle that's like down here. That's the one that I had the graph of. Not sure why it turned it into a square. Anyways, so I'll probably change the wording of this to define that t is a positive constant, but this is how you can do it in Desmos using regression. It's just for some reason, and I haven't figured out, exactly why yet, you have to basically divide everything on the left by 2 compared to the right. I guess so it's just x squared and y squared instead of having like the 2's in front of them, because those basically mess it up. Anyways, I hope you enjoyed this first problem set from the November 2024 Digital SAT math test. Have any questions or comments or alternate solution methods, please do leave them below, in the comments. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, sign up for notifications, and also be on the lookout for part 2 and part 3 from the November test as well.